So our next unit is chapter 1. We will be looking at squares, square roots, the Pythagorean relationship, and then move into the Pythagorean theorem. Today's notes might take a little bit longer because I want to do a warm-up first. So there's a lot of new vocabulary that I will be introducing. You can take out a piece of paper and just title it warm-up. So this is something we would have done on the whiteboard together as a class. And I'm going to go back in time. There was a group of old Greek mathematicians. They were really interested in mathematics, and in particular they were interested in squares and triangles. What they did was they arranged pebbles. They arranged them in rows and columns. They made squares, and what they did was they discovered something called perfect squares. So I'm going to try to show what they did. So they had a pebble of just one, and next, if they wanted to make a perfect square, they needed 4 pebbles. If they wanted to make another perfect square, they needed 9 pebbles. So here you can see it's 2 by 2, 3 by 3. Hopefully you can see the pattern and predict the next number of pebbles you would need to make a perfect square. So 4 by 4. Which is 16. The next one would be 5 by 5. And I could keep going, but I'll stop here and then use this to explain. So 5 by 5, which is 25. So these numbers here, they discovered were called, so these were numbers that made perfect squares. So they were called perfect squares because that's what they did. So if we took 10 pebbles, for example, we could not arrange 10 pebbles to make a perfect square. We could arrange them to make a triangle, but not a perfect square. 20, if we had 20 pebbles, we could not make a square. We could arrange them 4 by 5 or 10 by 2, which would make a rectangle, but not a perfect square, right? So next, so we could do 5 by 5. Next would be 6 by 6, which is 36, and so forth. So these numbers here are very special. They're called perfect squares. And then what you can do is, if you take the square root of that particular number, so if I wanted to take the square root of 4, basically you're saying what times what gives you 4, and it has to be the same number. So the square root of 4 would be 2. The square root of 9 would be 3. The square root of 16 would be 4, and so forth. So I printed off I attached a sheet of paper, and on it we have a number. We have all of the perfect squares listed. So you can print off this piece of paper or just continue writing on the paper that you had previously. And these numbers here, these are all perfect squares, right? So we went up to 49, but we could have gone further here, 8 by 8, 9 by 9, 10 by 10, etc. So what I want you to do is just fill in the square roots. So the square root of 1 is 1. The square root of 4 is 2. The square root of 3 Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. The square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. And then we went up to 10 here. On the second page, I would like us to just do a few more. So the next number after 10 would be 11. So 11 times 11 is 121. So that's a perfect square. Next would be 12 by 12, which is 144. Next would be 13. So 13 times 13 is 169. So these are all perfect squares here that I would like you to memorize, right? So if we were in a classroom, I would say, is 64 a perfect square? And somebody would put up their hand and say yes. Then I would say, is 50 a perfect square? And no, there's not two numbers that you can multiply by themselves to give you 50, and it's not on this list here. So before we move on, I would suggest pausing the video and memorizing these perfect squares. So when you take the square root of them, you get a whole number. Okay, so having that chart next to you, I've just put up a few questions. You should be able to go through them and give me the answer because you should have this memorized. So is 100 a perfect square? Yes, it is. Is 45 a perfect square? No. What is the perfect square closest to 45? So it's 49. Is 81 a perfect square? Yes, it is. And then what's the square root of 9? So what's the square root of 9? We know it to be 3. What is the square root of 64? We know that it is 8. What's the square root of 169? We know that it is 13. So you should be fairly comfortable with the vocabulary of a perfect square, of a square root, etc. And now, okay, so next I'm going to show you how to calculate perfect squares using your calculator. So if you have your every calculator is slightly different. So if you're having trouble with it, just send us a message and maybe we can help you to figure it out. But for example, if I want to take the square root of 36, now I've already memorized these answers. I know that 36 is a perfect square. The square root of 36 is 6. But let's say I wanted to do this in my calculator, because we will be getting into numbers where when you take that are not perfect squares. So in my case here, there's my square root key on top of this button right here. So I have to go second function square root, and then I type in 36. And I end up with 6. So please pause the video, make sure you know how to use your calculator to get this answer before we move on, because next, let's see, what is the square root of 225, right? Some of you might have good mental math and you would know that, oh, it's 15 times 15, but if you didn't, you could use your calculator, type in 225. The square root of 225 is 15. So 225 is also a perfect square because it gives us a whole number, right? We didn't go that far on our chart. We only went up to 13, but we could have kept going. Square root of 196. So you can try that in your calculator. So square root of 196 is 14, right? So 196 is a perfect square as well. Now let's look at some numbers that aren't perfect squares. So I mentioned the number 50, for example. So 50 is not a perfect square, but we can still take the square root of this number. It will just give us a decimal. So we don't expect you to have these memorized, right? You would know that it's between 49 and 64, so that it's between 7 and 8 if you wanted to estimate it. But putting it into our calculator, we have an answer of 7.007. Okay, so 50 is not a perfect square, but we can still take the square root of this number and it gives us 7.07. So it's pretty close to 49, which gives us 7, right? So that's a way to estimate. We're short on time, so we're not going to do the estimating lesson. So I expect you to be comfortable using your calculator going into the lesson, comfortable knowing perfect squares, square roots, and the last thing is I'd like you to be comfortable knowing the term square of a number. So if I ask you to find the square of a number, so if I ask you to find the square of 4, what I'm asking you to do is find 4 times 4, which is 16, right? Another way to write that is 4 with a little 2 on top. That means 4 times 4, which is 16. So what is the square of 7? So what I'm looking for is 7 squared, meaning 7 times 7, which is 49. Okay, so 7 squared is 49. So the square of 7 is 49. One of my favorite examples to do is 9. Okay, so what is the square root of 9? This is a really good quiz question as well. So the square root of 9 is 3. Okay, what is the square of 9? And what that means is what is 9 times 9, or 9 squared, which is 81. So this was our warm-up. I noticed it took almost 13 minutes. So you can take a break and I'll start the lesson in a separate video, So I'll stop this here.